Hello, everybody. Thank you very much for being here. My name is Lalo, and today I'm going to be talking with you about the principles behind designing for machine learning. But probably further than that, I want to talk about design as a key element of successful ML-enabled products. So let's start with why. Why is this important, and why you should care about this? Well, machine learning is changing the way we interact with our products. So, for example, with voice assistants like Siri and Alexa. But it is also changing what we buy and the way we buy things with suggested products and super targeted ads. It's changing what we say, the way we write with products like autocorrect and Grammarly. And it's changing the content we consume and the information that we see on the products that we use. And it's becoming part just of our day-to-day lives, probably to the extent that it's not uncommon to be in a conversation where we talk about how good or how bad the algorithm of a certain platform is. And now for products and for businesses, this opens a lot of opportunities. A lot of opportunities to actually improve the user experience by making it more natural, more interactive, or probably just smarter. But at the same time, for the teams that are building these products, this opens a lot of questions. And I think that that's exactly what happened to me. So a bit of context, I joined Quora a bit less than a year ago. And I specifically joined the team, the distribution team at Quora, which is the team that owns the parts of our product that adapt to our users, that adapt to our users. So for example, that includes their home feeds and the content that they read on them, but also the notifications they receive, etc. And so, in short, I think we can say that my team is in charge of using machine learning to create a different and a unique experience for every person that is using our product. However, it's important to note that we don't only care about making the experience unique and different. We also need to make sure that that experience is always the best and that they see the content that they will like the most. Now, as you can probably assume, the best is different from person to person. So another challenge that we have is that we must be able to learn what each individual person likes and then be able to do that for hundreds of millions of users. So when I joined the team and I got presented with this challenge, it naturally led me to question, okay, so how do we actually design a product that learns from its users? And the path to learning this and to learn more about this has been really, really interesting. But I think that we should, that to understand this and to get to an answer, we should first understand what is machine learning actually. So in a very, very basic form, machine learning is just a method to make a prediction based on a series of previous data points, right? So let's illustrate this by imagining that we have these shirts. And let's imagine that we wanted to know which one will a specific person like the most. Well, to do that, we should probably first start by understanding or by seeing some examples of other shirts that this person has liked in the past. That way we can get a better sense of their particular style or their taste, right? So in machine learning, we call these examples our training data. And it's our training data because this is the data that we will actually feed into our models that will eventually make a prediction. Now, in this particular case, we can see that this person actually prefers shirts more on the blue tones or on the cooler tones of the spectrum instead of the warmer, right? So if we went back to the previous options that we had, we can probably assume that this person will be most interested in this particular shirt. And so that's our prediction, right? And so let's take a look a bit again at what this process is. So we initially have our training data, which are the examples that we get in order to get a sense of what this person likes. Then we feed that into our model, which will actually be the one understanding what the style of this particular person is. Then we will, once we get an understanding of their style, we will be able to make a prediction based on that. and that's what we will show that person or that user. And so once that we have a prediction, that's so far what we've seen. But what I did not mention before is that once that we have a prediction, the user can actually rate this prediction back again. So we show the shirt that we selected and that we thought that the person was gonna like, and then they can tell us again whether they like it or dislike it, and that will eventually become one of the examples that we will show our users again, or sorry, that we will eventually feed into our model again, so that it can keep on learning what the preferences of this user is. And that's exactly what platforms that rely on machine learning do. So let's take a look at YouTube. YouTube will take a look at the videos that you have liked or disliked in the past, and then feed all of them into a model so that they can make a suggestion, and so they will offer a video that you will probably enjoy. And that's machine learning in practice, which I think is pretty cool. However, this comes with a very important caveat that we should always be aware of, and that is that our predictions can only be as good as the data we have. So if we don't have good examples that help us understand what that person likes, then it's going to be very, very hard for us to actually make a good prediction, and a prediction that they will eventually like, right? So this part of the process, the part where we collect the training data or the examples that we will feed into our models, is one of the critical steps for us to actually be able to build a whole ML-enabled product. And it's especially in this critical step of the process that design meets machine learning. And how does that work? Well, the way that they work is that design enables machine learning by creating interfaces that capture the user's preferences. So in short, it's our role to help our ML models to get the right examples and then offer the good prediction for our users. And now you might ask yourself, okay, great, this is really interesting, but how do we do that? And well, to do that, we rely on signals. And what are signals exactly? Well, I've defined signals as interpretations of user intent, and that, put in a more simpler way, just means that we try to read between the lines of our users' actions to try to understand what they mean and try to understand what the user preferences are through those actions that the user does on our product. And so I remember that when I joined Quora and I started working on this, I tried to go on the internet and learn a bit more about this. And I was trying to find maybe a framework or a model that I could use in order to get some guidance on how to improve my work and how to make sure that the work that I was doing was effective, right? Sadly, I could not find any. And so that's exactly what motivated this talk. So today, I want to share with you what I've learned in the past months working in these types of problems, so that hopefully you will find this useful. So now here are a few principles that I've learned for designing for machine learning. So principle number 1 is explicitness. And explicitness refers to how clearly the user intent is expressed through an action that the user performs. So this means that all of our signals can be explicit or implicit. Now, explicit signals are probably the easiest to understand because they are very intuitive and easy and just very straightforward. So these are things like liking or reacting to a post on Facebook, or things like subscribing to a particular channel on YouTube. Now, in this case, we add these types of buttons and these types of interactions because we want to help our users to express their preferences in the clearest way possible. And so if we actually accomplish that, then there is no reading between the lines for these sections. We don't have to assume what they mean because the user is clearly telling us what they like and what content they are interested in, right? And so if there's no reading between the lines, then it's pretty easy to follow up and to act upon them. So, for example, let's imagine that you actually react with a sad face to a post in Facebook. Then they can if they end up following up by showing you more content that makes you react the same way, this would probably lead to a very bad experience. So I assume that they would probably avoid that and instead try to offer a more balanced mix of the content that you will see on your feed, so that your experience is better and that you just enjoy using their product more. And that's exactly what probably YouTube would do as well. So if you subscribe to a channel, then they get a sense of the types of topics or the type of content that you're interested in, and they will try to show you similar content so that you will enjoy your experience the most. Now, even though like these are like the best signals we can get because they are like a clear expression of the user intent, we cannot always rely on them, and they are not always available to us. So whenever we cannot do that, then we rely on implicit signals. And what are implicit signals? Well, implicit signals are the ones that force us to make assumptions of what the actions mean. And so this means, for example, in Pinterest, they will show you, if you open a story or if you expand a story in your feed, a specific image on your feed, they will show you similar content to it in the bottom. So I think that they will probably just get a sense, or they will measure the amount of time that you will spend scrolling and just navigating around that related content to get a sense of how much, or to quantify your interest in that particular topic or in that particular author or user in general. And that's probably the same that TikTok does. So I assume that they measure the amount of time that you spend looking at a particular video to get a sense of whether or not you like that content. So if you actually watch a video like to completion, they will probably assume that you like that content. And in the same way, if you like skip to the next video after just a few seconds of seeing it, then they can probably assume that you're not interested in that and show you more or less content respectively, right? And I think that this is just pretty cool. So that was principle number one. So let's move to the next one. The next one is frequency. And frequency refers to how often the action that provides the signal is performed. So this is very important because you can probably imagine that if we don't have enough examples that tell us what the user likes, then it's going to be also pretty hard to get a sense of their preferences in general. And this happens even if the little examples we have are pretty good. So having a signal that is performed like pretty often is really important to us. Now let's look at an example. When a user bookmarks a tweet on Twitter, I think that they are actually saying that they did not only enjoy reading that content, but that they find so much value in it that they actually want to go back eventually. So I think that this is a really valuable signal to for them to collect. The user is clearly expressing what they want. However, I assume that not a lot of users do this because, as you can see, the feature is not like very easily accessible. But probably even if it were, probably not a lot of users will be doing that for a lot of content because they will only do it for a very limited amount of tweets that they find really, really valuable. So that's probably why they won't be able to rely on a signal like this to only on a signal like this to train their models, right? And then there are some other products that actually have made signal collection like an essential part of their experience of using it. So for example, let's look at Tinder. In order for you to keep using Tinder and to keep interacting with the app, you need to provide the signal that you like or dislike. You need to just keep giving that signal, right? The like, dislike, or super like. And if you stop doing that, then there's no way for you to keep on using the product. And so I think that this is a signal that was clearly designed with frequency in mind. So just a great example of how this principle can be implemented in real life. Now, that was principle number 2. So let's take a look at principle number 3, which is specificity. For this, let's start with a very simple example. Now, let's imagine that a user on Quora upvotes this post. Great. So now we have collected a very explicit signal. The user is clearly telling us that they find value in this content. Awesome. Now we have that signal. Now we want to follow up with that, and we want to show that user more content than the one they just liked. Great. So more content similar In which way? Like, why did the user upvote this content? Is it because the author, did they like the author? Is it because of the content itself, or because of the topic that the user is talking about in this particular post? Is it because of the image? Is that what they are mostly interested in? Well, it's pretty hard to know. It's pretty hard to know. And so this principle refers or focuses on us understanding what the user's action is attributed to, because this is a really important step for us to be able to actually show more content like the one that we just, or like the one that the user just reacted to, right? And so, okay, this is a pretty hard challenge, but how do we solve it? Well, an example of how do we do this is with UIs like this. So for example, when you hide a story in Twitter, they will show you this menu here, where they are basically prompting you to respond like, why didn't you like this content? Is it because of the author? Is it because of the context that it was shown in? Is it because of the topic? Is it because it's not recent, or because it's just not relevant to you? And so when you respond to that sort of poll, then you are telling them what your preferences are. And so you provide a clear way for them to act upon it and to follow up to make your experience better in the future. In fact, they are actually stating that. So they say Twitter will use this to make your timeline better, which I just think that is really, really interesting. So that was principle number 3. And I have one example more of this. I think that's probably one of the reasons why TikTok will only show one video at the time instead of other products like Facebook, where you can actually see like multiple stories in your screen. Because like whatever it's the action that the user performs when looking at that video, then they can be pretty certain that the user is actually responding to that specific video that the user has on their screen. So that's just another great example of how specificity can be added to your designs. So that was principle number 3. Let's look at the 4th and final principle, which is consistency. Now, this principle was the last that I actually learned about, or the last lesson that I had when working on this. And probably to explain it, I need to tell you more about the story behind it. So at Quora, we used to capture a signal when the user expanded the content. So when they clicked on that read more button that appears on the story. Because in our heads, if a user reads a preview and then expands the content to keep on reading, they are probably interested in that type of content. So that makes a lot of sense, right? And it actually worked for us, or at least that's what we thought. Because a few months ago, we discovered that there was a big flaw in this signal that we were capturing. And that is, and you can probably assume what that is after looking at how short content is displayed in our product. As you can see, the read more button is not shown here, and the users are not able to expand this story. Now that's obvious because like there's no more content for them to read. But at the same time, that signal was not being collected in our product. And that led to our models to think that these shorter stories were not as valuable to the user as the longer ones. And so that was clearly a mistake because like the length of a post is not related to how good it is. So that's why I learned that we must make sure that we capture signals only on actions that can be measured consistently, or that at least we know when that is not happening so that we can compensate in some way. And so that our models can adapt to that and make sure that we lead to the best results here. Now, a product that I think that has made really good, or that has a really good understanding of this principle is Instagram. Now, why Instagram? Well, if you see and if you navigate their product, you will see that you can only submit an image in 2 different sizes. So the image can only be a square or a rectangle with a very particular with very particular dimensions. And so this leads to them having like very consistent size or height in their stories. And I assume that they also rely or that they measure the amount of time that you spend looking at that particular story in your feed. So if the sizes are consistent, then they will be able to, there will not be inconsistencies in the amount of time that a story appears on your screen, even when you are scrolling longer images, right? So this is just a signal or a product that clearly takes consistency into consideration when designing and when making their product decisions. So this was the last principle, and now I want to go back to the initial question that we had. So how do we design a product that learns from its users? Well, I think that I've answered a bit of it so far. And so the answer is we design features and interactions that use signals, and these signals are ideally explicit, frequent, specific, and consistent. Now, like we really hope that all the signals that we collected were this way. Unfortunately, in real life, that's not the case. And so we will have to be able to balance these different attributes for each different type of signal. So some signals will be like very frequent, but not explicit and not consistent. Or some of them will be very explicit and they will clearly tell us what the user preference is. But they will happen only a few times and probably not be very consistent or not very specific. So maybe a good example of this is Twitter bookmarks, as we shared before. So it's very explicit. The user is telling a lot of information with that signal or with that action, but it probably won't happen but like very frequently, right? And so how do we work with this? Well, the answer is that we don't rely on just one signal. So if we can actually get a mix of different signals that we can collect, then we can probably get to a much, much better result. And we can learn from the user, not only when they perform one action, but probably through their entire behavior across their product, which will actually like yield the best results for our platforms. Now, how do we do that? Like, how do we select the signals that we will be able to collect or that we want to capture? Well, we will do that by discussing with the ML team. And so I just want to say that as in a lot of things in life, communication is key. And I think that it's really important for us to have first a shared language that we can use when discussing about these types of problems, because designers and machine learning engineers will probably speak like very different languages and in very different technical terms. So having a shared language and having some shared principles that we can use when discussing is pretty valuable. Then if we actually get alignment on this, we can probably lead to the best results that we have. And now let's just wrap up by saying that I really hope that you find these principles really useful if you are working in these specific types of problems. But at the same time, if you are not, and then I hope that these principles and that this whole framework allows you to look at ML-enabled products through a different lens, that you are not able to understand or at least imagine what the design decisions behind these products are and how your interactions with these products can actually make your experience better. However, also, if you are not working in these types of problems but are interested in these types of problems, you might want to work at Quora. We're actually hiring for a number of different roles in a lot of different functional areas. So you can go to this page and apply. And finally, I just want to say that, as I said, this is me sharing what I've learned in the past, right? What I've learned in the past few months, actually. But I think that there's a lot more to learn. So I would really want to start a conversation around these kind of topics. And if you think that I'm missing something or you just want clarification on whatever that I just mentioned before, feel free to reach out on Twitter and we can start a conversation. That was it. Thank you very much.